Hello and welcome back. In this lecture I want to talk about writing to a file. We're going to concentrate on writing to a text file. What we're going to learn about is how you can write characters, how you can write strings, and how you can write formatted output. The three ways also that we were able to read. So there's three functions that you really have to be familiar with in order to do these things. The simplest write operation is provided in the function fputc. So just like there was an fgetc for reading characters, there's an fputc for writing characters. This will write a single character to a text file, fputc. Not as efficient as writing strings, but sometimes necessary. It takes an integer as its first parameter and a file pointer as its second parameter and returns an integer. The function writes the character specified by the first argument to the file identified by the second argument. So the file pointer represents what it always does, the file that you want to write to. And then the character you actually want to write to is your first parameter. The returned character is what was written if successful. Remember, if it returns EOF, it means it was a failure. If it returns anything other than EOF, it means it was success. In practice, characters are not usually written to a physical file one by one. It's extremely inefficient. The putc function is the equivalent to the fputc. You often see this used as well. It requires the same arguments and the return type is the same. The difference between them is that the putc may be implemented in the standard library as a macro, whereas fputc is a function. So not a ton of differences, but we haven't learned about macros. So we're going to stick with fputc for writing single characters. And for an example, it's pretty straightforward. First thing you have to do as always is you have to open up the file. Before that, we do declare our variables. We declare our file pointer, should be initialized to null, and then our integer, which we're going to write. When we open up our file, you'll notice that we do a W or a W plus. W means that we're going to write only. You can't read. W plus means you can write and read. In this case, we can write and read. Here we have a for loop. We're going through all the characters starting at 33 to 100. When these are integers, what this means is the character is represented in the ASCII table. So if you write character, for example, 59, you'd have to look it up in the ASCII table to see what it represents. But it would be an actual character. Here we're just writing ASCII values 33 to 100. And we're saying fputc char fp. And you could use conversion functions if you wanted to create ASCII values to integers. You can just use an A2I. So if you wanted to write the character C, you could say fputc A2I and then put C in single quotes. That would be fine as well because it would convert the ASCII to an integer and write it. But the first argument is an integer, so you have to write an integer. And the second argument is our file pointer. Pretty straightforward there. And then the last thing we have to do is we have to close that file. Right. We probably also want to set the FP pointer to null. But again, it takes an integer, so be careful there. It's always represented in the ASCII table. But you can convert the integer, the actual characters to integers using A2I. How about writing a string to a text file? Much more useful, more efficient. This is where you use the fputs function. This will allow you to write to any file or stream. It is similar to the fgets. It takes a constant char string that you want to write as the first parameter. It's a pointer. And it takes as our second parameter the file pointer, what file you want to write to. And then it returns an int. So the first argument is our pointer, the character string that you want to write. The second argument is the file pointer itself. And the function will write characters from a string until it reaches the null terminator. It does not write the null terminator character to the file. So you have to write it explicitly. This can complicate things because when you read back the data, it could be variable length and it won't end at the null terminator. So you have to, it's expecting it to write a line of text that has a new line character at the end. So make sure you're familiar with the null terminator and either explicitly write it using fputc, a single character, or write it and it will basically add the new line character at the end after you write it. So it's expecting that new line character to be there. You have to explicitly specify that. This is pretty straightforward in terms of code. You just say fopen, fputs, writes a string in the new line using the file pointer, and then another fputs here writes another string, and then you close it. So in this case, we wrote two strings, two lines of code actually, or two lines in the file. This is C programming, and then this is a system programming language. And we opened up the file with W+, that's for reading and writing. The right examples are pretty straightforward. You just call a couple functions, right? fopen and then fputs and then fclose. Now, for writing formatted output, we're going to use fprintf. Again, you'll notice that with the scanf to read and input and the printf, you just add that f prefix before the function and you're writing formatted output. So for writing formatted output with the fprintf, it returns an integer, it takes a file stream as the first parameter, and then the format specifiers are followed by commas with variable number of arguments for each format specifier. Just like printf, really. The first argument to the function is the pointer to the file object, and then the second argument is those variable number of arguments. It's a C string that contains one or more of the following items: white space character, a non-white space character, format specifiers, and again, it's very similar to printf, but you're actually writing to a file. So you can write formatted output to a file. If it's successful, it will return the number of characters written. Otherwise, it's going to return a negative number if it's not successful. It looks something like this. You include the standard I/O header. You create your file pointer. You then use your file pointer to open up some text file. Use it for W+ for reading and writing, and then you just say fprintf. In this case, we're saying fprintf. We're specifying the file pointer, and then we're specifying 4 strings separated by a space and then a %d. And we're writing, hello, my number is 555. So the file is actually going to have the data formatted when you write it. So let's look at this in code blocks and see what it looks like. So there's not a lot of code in here. We only have a few lines of code. On line 4, we're creating our file pointer, and again, we'll want to initialize this to null. We then, in line 6, we call fopen, and we say open file.txt. So that file.txt has to exist in either where the C source file is running, or if you're executing the program manually, wherever the executable is. We're going to open up for reading and writing. After we've opened it up, we do want to make sure the file pointer is not null. So we want to say not fp. If it's not null, then we can start writing data. And in this case, on line 9, we're going to write formatted data. So what we're going to write is we're going to write 1 string, 2 string, 3 string, 4 string, and then an integer. And then the next parameters are just comma separated strings, as well as our integer at the end. I just have to fix these double quotes because it doesn't work right. So 555 is right at the end there. And it's going to then close the file and return it. So let's go ahead and try to build this and run it. And we're not going to see any real output for running. We're going to have to look at what the file looks like. So when we compile this file, you want to make sure your if statement, it says not equal to null. To do a not fp is not right. Make sure it's not equal to null and then print to it. So when we run this, again, you're not going to see any output. It's just going to run. And then when you look at the file inside the directory, you'll see that it contains the input in a single line. Hello, my name is FPP, or F555. So that's how you can write formatted output. It's pretty straightforward. You could add new lines if you wanted to. It will add a new line at the end, but you couldn't. You could put \n here, right? Because it's used. It works just like printf. Again, we have to run it. We don't really see any interesting output until you look at the file. And in that case, you see a line feed. So writing output to a file is pretty straightforward. You want to write characters, you do fputc. You want to write strings, fputs. Formatted output, fprintf. We'll have some challenges that help you get even more familiar with this, but pretty easy to write output to a text file. Thank you.